Hey there! Today I'm going to demonstrate how to build Android operating system for the i.MX8 MN, that's the Nano series, from scratch. So before we begin, I just want to introduce this channel. So I'll be posting videos from gaming to debugging microcontrollers, microprocessors, embedded tips and tricks, and many more to come. So let's get started. So before we begin, we need to set up the environment for the building. So let's first visit the developer arm and look for the GNU A, which indicates this for a Cortex A family. Scroll down all the way till you find the x86 Linux and download this ARC64 non-Linux tar file. Once you have extracted it to the preferred folder, avoid extracting it to an NTFS or FAT32 partition. I usually extract to /opt/ the compiler. Then go ahead to the NXP website and search for the i.MX8 Nano evaluation kit. Again, scroll all the way down and search for embedded software. So you can see there's a Android Q source code. Download it, provided you should have an NXP account. So once you have downloaded, again I would prefer somewhere like your home directory. I have set it up in home directory. So before we can proceed again further, you need to even set up repo, which is more of a based off Git. Follow the instruction here and you should have the repo Python script set up. Then you can go and first ensure your username and email ID set up for the Git, and you should run the script repo sync. Once you have downloaded the i.MX Android OS source, so you go ahead and do the initial sync. That's by source i.MX script. So this should go ahead and fetch the complete source directory. That's Android build, you can see here. But I'm going to cancel this because I already have it fetched. So what I usually do is that the Android build folder, I move it to my home directory. As you can see here, I have already moved it. So I do the initial environment setup. That's by source build environment setup. So this should set up the environment, and then I'll initiate the launch. That's 38 for the i.MX8 MN series. Just verify it's the right processor for you here. So once you are done with that, you have to export the compiler. So it's pretty much set up for me. So I do that and then go ahead with the actual build. So to do that, you just initiate the i.mx8.sh. This should initiate the build sequence. This will typically take from 15 minutes to all the way till 1 day, depends on your processor and your hard disk read-write speed and also your RAM capacity. So it's going on. I will pause and resume once the build sequence is completed. In the meantime, you can also initiate the another method where you specify the threads. So my computer is a 16 thread, but I usually execute 4 simultaneous tasks because I've seen it fail in 16 threads or 8 threads. So let me change it to 4 so that at least 4 threads are executed in parallel. I'll resume back once the build is completed. As you can see, the build is complete, so the next step is to go ahead and flash the build, but you have to ensure that you have the right partition. In case of me, that's SDC, that's my 32 GB SD card. So just ensure that you have the right partition. You can see here SDC, so it will be different. And another thing you need to take care of is this 28. Since it's a 30 GB pen drive or flash drive for me, it's 28. But if you have a 16 GB SD card, that would be 14, and if it's a 8 GB, that would be 7. It's pretty much a multiple of 7. I haven't tried this on 64 GB, and I doubt it even support 64 GB. But yeah, so I'll go ahead and try to flash. Yep, this should again take a couple of minutes because the images are quite large. So I will go ahead and pause the whole thing. It has finished flashing to the SD card. The next process is final booting the Android from SD card. Before we go ahead with the actual boot process, I just want to give an overview of the setup here. So if you can see there are 3 USB ports, type C, both, and 1 micro USB. The first port is primarily for powering this board. There are no data communication happening over here. The second port is for the OTG or host mode. So I've connected the OTG converter and mounted a USB dongle, the mouse dongle. So here I'll be using it as a OTG mode. But if you want to debug this board over USB, this is the port you need to connect to your computer. And the last port is primarily for the debug logs. So when you connect this to the computer, it will pop up as 2 COM ports. So you just have to select the second COM port because the first COM port will not dump out any logs. And moving on, we also have the Ethernet connector. So in the further videos, I'll be showing how to debug over Ethernet your Android app. Okay, and last but not least, the MIPI DSI to HDMI converter. So this converter is pretty much provided by the NXP, so you can hook it up and then connect to your monitor. So with that cleared up, let me take the flashed SD card and insert into the slot. There is a SD card slot on the bottom, and this is the power switch to turn on the board. So let's begin in 4, 3, 2, 1. As you can see that already the device is booting up, the LED indication, and then let me switch to the monitor. You should see a tux, and tux indicates that it has booted into the kernel. Now it should start jumping to the actual Android framework. You will see the Android logo. Yep, that means it's booting the Android. Since this is the first boot, this should take considerably longer. Plus, since we are booting on a slow SD card, the interface should be a little choppy. So it has booted. So since I have hooked up the mouse, you can see that I have a cursor. Let me go to the settings. System. So basically this is right now not in developer mode. And finally to the tablet, it shows EVK8MN with Android 10. In the upcoming videos, I'm going to demonstrate how to toggle GPIO on this expansion port. This is basically connected to an IO expander. So I will show how to do that from the Linux shell. As well as you can see, I have connected a USB to UART converter. The purpose of this is that there's a UART 3 here. So also I'll be demonstrating how to enable UART3 from the TTS in the kernel or in the U-boot, and then get it working. And also similarly, we have a SPI bus exposed. We'll be demonstrating that as well. And as explained earlier, since we have an Ethernet port here, we can debug the whole Android app over Ethernet rather than the USB, and you have the USB port free for the mouse or maybe hooking up a pen drive, anything. So that's all I had. Thank you so much.